Today I wanted to talk about another of our 18 dimensions. Today I wanted to do the dimension of color. The dimension of color is the 15th dimension of our 18 dimensions of motion. And so I'm going to read a few things. I have a few diagrams, um, and hopefully this will, just be another dimension, and we'll connect this dimension kind of with the other ones so that you guys can kind of see how it's all related, because all the 18 dimensions are related, and connected, if you will. So Walter says light is the universal language. The colors of light are the letters of the alphabet. And so combinations of the letters of light are the words of the language of light. So simple effects of motion are simple words of few letters. And complex effects of motion are complex sentences and paragraphs with long words of many letters. Every effect of motion is cumulative and repetitive within its accumulation. Every effect of motion in any octave is repeated in sequence in the various speeds of every other octave. In Russell's periodic table, he has octave one, first octave, second octave, third octave. He's broken it up, into 10 octave. Well, it was 10 octaves in the universal one. And then later on, this one is actually from Atomic Suicide. He changed it to 9 octaves because then essentially it just repeats. It's like the beginning is the end and the end is the beginning. So what he's saying though is that, like, once something happens, like it could be in the first octave, it's going to continue and be repeated going through the second octave, the third octave, the fourth. It's going to run the entire cycle from the first octave all the way to the ninth octave. And that's like just how, he says once something starts, it never stops. It runs a whole life cycle. You could say it stops when it's at the end of its cycle, but then it just starts another cycle. It's just repeated again. My alarm is going off. It's telling me we only have less than a minute. So I'm gonna sign off, and we'll log back in for the second half, and we'll get deeper into color. Okay, so we are going to continue with our discussing the 15th dimension of color. He talks about how, a simple effect of motion, such as hydrogen, is written in the language of light in simple words and simple letters, for its history is brief. So like the spectrum of hydrogen. Oh yeah, and let me share another. Oh, let's make sure we're sharing this screen. 1 second. When we talk about an event or an effect of motion, he's talking about effects of motion. And, like an element of, say, hydrogen, like that is an effect of motion. And so, as we showed you the periodic table before, effects of motion will run the entire cycle through all octaves. And let's see here. So scientists came up with a way to look at this language of light through the spectrum of light. So I have a little, let's see, graphic here of the continuous spectrum. Now, this is the spectrum that we can see with our human eyes, right? And so there's examples like where each element has its own specific absorption spectrum or emission spectrum. Okay, and this is just kind of the example of, the continuous spectrum, the absorption spectrum. You see these black lines, and then this is the emission spectrum, where it's the colorful lines. And so Walter talks about, the spectrum of hydrogen is preponderantly red, and that preponderance is recorded dominantly in one bright line of red and less conspicuously in three other lines of red, which indicate similar positions. Okay, I actually have to pull up one other photograph for you guys for this to make sense. Okay, well, I'll describe this. So this is the periodic table from the universal one, and it's separated into 10 octaves. Okay. And the way that he talks about them, for example, if he's talking about hydrogen, which is right here, hydrogen is in the fourth octave. Here's the fourth octave. And so he talks about position 401, which would mean the fourth octave, and this is position one. Then ethlogen would be number 402. Bebagen would be 403, and carbon would be 404. So that's kind of what I'm talking about when I'm about to read what I'm about to read here. So, you know, he says that the spectrum of hydrogen is preponderantly red. Okay, one other thing I need to explain also. One more time, going back to this diagram. Okay, so when we look at our formula of the locked potentials, once again, we always remember this is the cycle, starts at, I guess you could call it zero, and then it goes +1 at lithium, +2 beryllium, +3 boron, 4 plus plus, then -3, -2, -1. Now, he talks about this as the plus side, the 1, 2, and 3, that is the red side of the spectrum. Okay. And then the -3, -2, -1 on this other side, this is actually referred to as the green side or the blue side. He started calling it the blue side at first, but then later switched to calling it the green side. Um, because there was actually a little bit of confusion because there's actually blue on this side. Right near the bottom here, there's like a violet kind of blue. So there's kind of blue on both sides. Um, but there's not red on both sides and there's not green on both sides. So later he started calling this the red side, which would be the male side or the positive side or the gravitative side or the side where things are prolating. And the other side would be the negative side or the female side or the side where things are oblating. Um, and so that would be the green side. All right, so I just had to explain that first as I'm reading this, what he's talking about here. So he said that the spectrum of hydrogen is preponderantly red. So here we are, hydrogen. So going from the 0 to the 4 plus position would be here at carbogen. And he says that the the spectrum is it's in one bright line of red. Um, and it has three less conspicuous lines of red, which indicates similar positions of 301 plus, 201 plus, and 101 plus of lower potential through which hydrogen had passed in preceding octaves. So what he's saying there is we have hydrogen here in the fourth octave at position 401. But he's saying that when you look at the spectrum analysis of it, you'll see a main bright line, which kind of represents this hydrogen 401, but you'll see three faint red lines that show its previous history of its evolution. So this is the fourth octave, but it was in the third, let's see, it was in the third octave at position 301. and it was in the second octave at position 201, and it was in the first octave at position 101. Is kind of what he's saying. It's like it started here and it's evolving and it's going to continue to evolve all the way through the whole cycle. But it's only gone through three octaves so far. So it's kind of a simple, when you its language, if you will, or its description of of hydrogen is a very simple description in light. Um, and it's shown. Let's go to the uh, here's an example of the emission lines of hydrogen. It's just a few lines. One, two, three, four. Now, then he says, on the contrary, the spectrum of a complex state of motion, such as iron, is written in the language of light in complex paragraphs of long, involved, and complex sentences, words, and phrases. The spectrum of iron is preponderantly orange yellow. That preponderance is recorded dominantly in its octave line and less conspicuously in six other lines of orange yellow, which indicate similar positions of lower potential through which it passed in preceding octaves. Now, let's see here. The effects of motion revealed by the spectroscope show the cumulative history of each separate state of motion written within itself. The octave waves of low potential, of which the elements are tones, are within octave waves of high potential. Like within helium is the history of its growth. Now, helium is a master tone, and helium itself is therefore devoid of spectrum lines of its own. The three red lines of helium are antecedents of hydrogen in octaves of the unseen universe. And when he says the unseen universe, he means the octaves that are before octave number 4, where because we can't see frequencies that low, they're below the visible spectrum of light. So he says, helium is a master tone, and helium itself is therefore devoid of spectrum lines of its own. The three red lines of helium are the antecedents of hydrogen in octaves of the unseen universe, and other prominent lines tell the story of the six empty spaces which follow hydrogen. Now, it's kind of hard to visualize that. Like, guys, you guys listening to this would probably have to go back and look at the periodic table to understand what he's saying, because he's talking about like different positions in different octaves. And if you do go to the periodic table, you'll kind of see what he's talking about. So let's see. Then he says, consider the spectrum analysis of iron, for example. One can see at a glance the lines which belong to iron and those which tell its recent and remote history. So down here is the spectrum of iron, and look at that compared to the spectrum of hydrogen. And this is exactly what he's pointing out. It's like, hydrogen is kind of new. So it's got just a few words of the language of light, whereas iron, which is, had a much longer journey, iron is in a much higher octave. So its language of light is more complex. And so you got all these different lines. And something that I had never heard before, Walter's describing that. Well, first let me say traditional science, when they invented this spectroscopy, the spectroscope would give these lines for each element, and every element had its own set of lines. And so like that's how they can use that to, for example, if they are like looking out at a star in space, they can see what kind of spectral lines they're receiving, and then they can say, oh, well, we know that star has some hydrogen in it, or it has helium in it. So that's how kind of current science sees those lines. They're like, hey, this is the spectrum analysis of hydrogen. We know it. It always looks like this. This is the spectrum analysis of iron. It always looks like this. Walter Russell takes it one step further, and he is saying, well, yes, these lines, are some of these lines are from iron, but what you guys don't know is that a lot of these lines are actually lines that are indicative of iron in previous octaves as it started from the first octave, and it went from the first octave to the second octave to the third octave. you know it had all of these lines, and so like the whole history of iron's evolution is printed here in all these lines. And to me that was quite fascinating. And he even, I'm not going to read all this, but he even, now this is in the unit for those of you wanting to go deeper. This is in the Universal One on page 204, or let's see, it would be in chapter 19, um, expressions of gravity and radiation, color, the fifth dimension. So it's in chapter 19, and it's on page 204. He literally lists down all of the frequencies of light. Oh, because each of these little lines represents a specific frequency of light. Okay. So he goes in and he lists down about, what is this? Probably 10, 20, he's probably got 100, I don't know, like 70 different frequencies that he's listed for iron, and which is each one of these little lines, and he's explaining how some of them are the more recent history and some of them are the more the much more previous history. So which is fascinating. But the point he's making here, let's see, is that right, okay, the division of the visible spectrum into several thousand lines, each one of which is different in its shade of color and its plane from every other line. Um, and of the invisible spectrum into thousands of other lines, tells in its own convincing manner that this universe of varying motion is a universe of varying pressures. So every state of motion is indicated by its own particular color line, exactly as it is indicated by its own degrees of temperature or plane or pressure. So color is one of the great dimensions by means of which we will be enabled to measure the potential positions of states of motion. And then he says, which man will soon need to reproduce for the continuance of his very existence. Now, I don't know what he's talking about right there, but like that's him like going into the future, I guess, saying that like eventually, I don't know, as our planet, gets farther away from the sun and becomes kind of uninhabitable, like we're gonna have to like be able to create things and manipulate things to stay alive. I don't know. It's you know, kind of deep there. But um he's saying that like every single one of these lines is at a particular pressure and plane and potential. And so color is really one of the great dimensions that we can look at and figure out something about that piece of matter that we're looking at, or that, that mass that we're looking at. So there's a couple other kind of general things to realize. So like yellow is the meeting point of highest pressures, temperatures, densities, and potentials of the wave. And, that was definitely, let's see, let's go back to this guy right here. See how they have yellow at carbon, and as we all know, pressure increases from, as we go on the positive side or the gravitative side, it is contracting, getting closer together. When it goes from +1 to +2 to +3 to +4, it's getting higher and higher pressure, higher and higher potential. And so yellow is the highest potential. Hey, that's why the sun looks yellow. So color, therefore, like temperature, is an indicator of a state of motion and has no existence other than an appearance of existence. Because once again, all dimensions of motion are just illusions. Okay. Let's see. All mass is both generative and radiative. All mass indicates its ability to generate by the color pressures indicated by generoactive lines on the red side of the spectrum, and its ability to radiate by radioactive lines on the blue side of the spectrum, or green side of the spectrum. So I'm reading from the universal one, so he's still calling it the blue side of the spectrum. So the preponderance of color lines of a mass is indicative of its potential position in its wave. A preponderance of red or orange indicates that a mass is on the outward journey toward the north, and a preponderance of green or blue indicates that a mass is on the return journey to plane. So charging systems, therefore, are preponderantly recorded on the red end of the spectrum, and discharging systems are preponderantly recorded in the blue end or the green end. That's kind of the connection, that we can kind of add color to our list of dimensions that we've learned about. We've learned that, like, temperature, as the gravitative force compresses, you know, mass into a smaller space, as it's spiraling down that centripetal vortex, getting smaller and smaller, we know the temperature is getting higher and higher, the pressure is getting higher and higher. And now we know that the spectrum of color is going in this direction, to red, to orange, to yellow. And then the the second half of the cycle, or the opposite, is the radiative portion. Now we know that that color goes, green, then to lighter blue, then to darker blue. And, that is the connection with, the potential lowering on the second half, on the radiative portion, to the volume expanding. So that's kind of the main connection. I'll read a few more things here, just to kind of hammer it home. Let's see. The spectrum of any element can only be obtained when that element is in a state of incandescence, which necessitates an increase of radiative expansive pressure. This fact has much also to do with the recording of the overtone of sodium instead of the true tone. Ooh, that's not going to make so much sense, because when I read from the universal one, I'm not reading all of it. I try to pick out little things, and this one is just something that is referencing something else that I didn't read. So, like, once again, guys, go get the universal one and read it yourself. But so let me skip this part and go to he said there's a great difference of opinion as to the direction in which evolution is proceeding, whether from the direction of white stars into the orange and red stars, or whether the colored stars are younger and will become white stars with increasing age. And he just says the red stars are the younger stars. They evolve through orange and yellow. So look, they're red here. They evolve through orange and then yellow, right? As they're getting gravitatively, they're in the gravitative stream, right? They evolve through orange and yellow to their white of maturity in the north apices of their cones, White in maximum motion is a reflection of white in inertia. It must be constantly borne in mind that standard units of pressures and other dimensions in a potential position such as that of the sun expand and contract to fit the standard units of measurements of this planet. Therefore, all pressure color lines that are visible in the high pressures of the sun expand in the same ratios when recorded in our planet's lower pressures, so that when so recorded, they maintain their same relative positions. That's one of the huge things about Russell's concept is this concept of universal ratios. So it's like you could see like spectrum color lines or something that's like near the sun, which is it's the sun is so far away from us. The sun is in a different pressure zone than we are. It's much, much higher pressure near the sun, or like the planet Mercury, the first planet closest to the sun, much higher pressure than us where we are on the Earth. We are way farther away from the sun than Mercury is. And so, therefore, we at a much lower pressure. And, you know, says that like one of the mistakes that current science is making, we're trying to measure things like say about the sun in our own kind of planet's pressure units, our own units for our planet. And he's like, no, he's like, it that's not correct. We have to take into account the difference in pressure. And science doesn't really do that yet. And so, but what he's explaining here is kind of that, like, whatever we're kind of measuring from the sun, like those spectral lines, you know, even though they're much different, they're in a much higher pressure zone. When we measure them, they've expanded, like they've come all the way from the sun, expanded out, and then contracted a little bit when they come to our planet. But the point is, they still keep their relative ratios. That's the concept of universal ratios. It's still the ratios are what are always correct, but the numbers are going to be very different from our pressure zone to the sun's pressure zone. And we make the mistake of measuring other planets kind of based on our pressures and like our planet's numbers. We will talk about more about that when we get to the section of universal mathematics. But one more thing he says here: it also must be constantly borne in mind that increasing pressures are recorded nearer to the yellow, so that lines of consecutive octaves of increasingly higher potential record themselves in the direction of yellow. And so then finally, he says, if therefore yellow by the way of red is in the generative direction of north, and let me point that out on here. So here's yellow. He says, if you're going to yellow by the way of red, which is on this side, so you're going this direction. Right. So if therefore yellow by the way of red is the generative direction of north by the way of east, and violet by the way of blue is in the radiative direction of south by the way of west, pressure color lines must, in some manner, be related to the attraction of gravitation and the repulsion of radiation. If the above premises are well founded and the color of a state of motion indicates the condition or potential of that state of motion, then color is as dependable a dimension as miles, feet, and inches, or degrees of temperature and plane. So that's how he kind of brings it all together. So he's just described color, and he's described how every single color is different than every other color. and each one has its specific, you know, a specific plane from 0 to 90 degrees. Each one has its specific potential. And let me just show you guys. You can see that the colors repeat. Okay, so you've got, red, orange, yellow, green. Well, over here, you've got red, orange, yellow, green. Over here, you've got red, orange, yellow, green. So they repeat, but the octave is different. As you go up the octaves, you get higher and higher potential. Okay, um, so each color has its own potential depending on what octave it's in. Um, it's kind of like musical notes on the piano. When we go up the piano one key higher and higher pitch, we say, for those of you guys who don't know, music theory or whatever, music notes would start, like A, B, C, D, E, F, G, but then, they repeat as you go up to the next octave, A, B, C, D, E, F, G. And that's the same thing. So like these colors will repeat all the way up through all the octaves. However, just like on a piano, even though the A, B, C, D, E, F, G is repeating, each one of those notes has a different pitch. It keeps getting higher and higher all the way up the piano. Okay. So it depends on, so the note A in octave one is different than the note A in octave seven. That note will be much higher pitch. And so it's the same thing with color, the way that he's described it. Um, you know, each color will have its specific frequency, but it depends on kind of what octave it's in. But um, but the colors, and I'll go right back to our this diagram
While we're
here,
in this
this
diagram,
evolution of mass from plane to sphere. What he's showing here is one cycle, one birth, growth to maturity, and then degradation to death, back to plane. That's one cycle, and then it would be repeated. And so color would just be in this one cycle. The red side of the spectrum is up here, and then the green side of the spectrum is down here. The red side of the spectrum is the gravitative portion, and then the green side of the spectrum is the radiative portion. That is how color is kind of integrated with the rest of the other dimensions that we have learned about. We learned about temperature, so it's just another dimension, and that's how it is connected with all the other dimensions. So I hope that makes sense. I guess seeing if you guys have any more questions, because I see we've got about 4.5 minutes left. But I think we're finished with color. But any questions about color, the color dimension so far?
I was
Like,
just wondering why hydrogen was in the +4 position in one chart and it's in the +1 position in the 10 octave chart.
ooh, ooh, let's see if we can pull that up. I think let's see.
See, hydrogen's in +1 there,
See if we can
and carbon is in +4.
see if I can
Mm.
do it side by side really quick.
You have to look at the Atomic Suicide book. That's the most current updated uh, chart from Walter Russell.
Yeah,
Because
so
in the
so
Universal One, he has 10 octaves, and he condenses it
Okay.
down to 9 in the other book because the first octave and the last octave were just repeating each other.
but I
Yeah.
have I have an
So
answer
what
for
about
you.
hydrogen though, swapping place with carbon?
You
Okay.
correct. I am going to tell you the answer to that. It is very simple. It is a typo. It is a typo.
Oh,
Is
okay.
this chart is from Atomic Suicide, and in that printing of the book, where I don't know whoever made this, added all these colors to it. He got this chart from Atomic Suicide, and atomic suicide has a typo where this says hydrogen is at the 4-4 position. That should be
Mm.
carbogen. Carbogen should be
Oh.
here, and you see how carbogen is in the +1 position. Over here, this is correct. This is the universal one. Carbogen
Mm.
is in the 4 position, and hydrogen is in 1 position. And I'm glad you caught that. I actually caught that myself, and I let the University of Science and Philosophy know. And so in the next printing of the book, which actually just came out, I don't have it yet, but they should have made that change in because that was straight up just a typo. So
But
good
in my
catch.
copy of A New Concept of the Universe, it's also got hydrogen in the +4 and carbogen in the +1.
Correct. Correct. And that's because they took that from sorry, the periodic table that was printed in A New Concept of the Universe was just a copy from um the same table that they used for atomic suicide. And so yeah, the typo is in both.
Follow through.
It's not
Okay.
that like those two are right and the 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 positioning in the universal one is correct. So like I said, the newest version. Oh, we only got we let's see, we're running low. We got about a minute left. But yeah, the newest version of atomic suicide should have that corrected. But you're totally right to point that out, you know. Okay, guys, we've got less than a minute here. So that was color, you know. If you have any other questions, you know, shoot me a email or chat in the group. All right, guys. Well, it was great. It was great talking with you
Thank
guys.
you.
Yeah, we'll see you next time, all right?
Bye.
All right, bye-bye.